In this video, we'll be looking again at note sheet D5, which is over vertical and horizontal shifts. Remember, horizontal shifts are also called phase shifts. And we are on page 2, the bottom. So we're looking at section 4. And in this section, we'll be combining a change in amplitude and also a vertical shift. So a change in amplitude, remember, is a vertical stretching or compressing. And then the vertical shift, of course, is shifting it up or down. And so we're combining the two vertical elements when we do this one. So the form of these functions is going to be a times the sine of x plus d, or y equals a times the cosine of x plus d. Remember, the a is going to affect the amplitude. The d is going to determine what the vertical shift will be. So we'll identify the amplitude, the period, the vertical shift, graph one period, and then finally state the domain and the range. So we have y equals negative 2 sine x plus 3. And so we know that the amplitude of that will be the absolute value of negative 2, which is 2. Remember, amplitude is always positive. But this one is going to have a flip. So we want to try to remember that as we're graphing it. The period of this, because the coefficient of x is 1, the period is just going to be 2 pi divided by 1, or 2 pi. And the vertical shift, because it's plus 3, will be up 3. So we'll start out with our x and y axis again. And you can start with whichever axis you want to. Because the period hasn't changed on this, the period is still 2 pi, we know that it's going to go through one cycle between 0 and 2 pi. So it might be easy to start with that. That just corresponds to what we've done with other problems. And then this, the middle will be pi, the quarter will be pi over 2, and this will be 3 pi over 2. So we've seen this quite a few times. All right, but now we're concerned about this vertical shift up 3 and then the change in amplitude. So what I recommend that you do for this is start out with changing where that principal axis is going to be. So remember again that when you're doing a sine graph, that the principal axis usually is the x-axis. But because the whole graph is going to shift up 3 units, that principal axis is going to shift up 3 units. And so our new location for the principal axis is going to be at 3. So I'll put that in first. And I'll even put in a little dotted line, remembering again this is not a horizontal asymptote. It's just indicating where that midline is going to be. Then we can take care of the amplitude. So the amplitude is 2, and what that tells us is that from that principal axis, from that midline, we can go up 2 units. So we'll be at 5, and then down 2 units, which will put us in at 1. And notice, by the way, that this is not necessarily drawn to scale, and we're not too concerned about that as long as we know the coordinates of any point on the graph. So now what we've done is we've identified where the maximum function value will be at 5, where the minimum function value will be at 1, and then we already know that the left is at 0 and the right is at 2 pi. So just as before, this is identified for us a little rectangle, and we know that our graph has to go in that rectangle. So now as we're plotting the graph of this, we know that we have a sine graph, and so we know that the sine graph will always be on the central axis at the beginning, the middle, and the end. And then normally, remember that at the quarter point, the sine graph usually goes up. But because this is a negative 2 in front, we know it's going to flip, so it's going to go down instead to that low value of 1. And then usually at the 3/4 value of x, it usually goes down, but this time it's going to go up, so it flips. So we can sketch that graph. And as always, I do recommend that you put that into your graphing calculator. Graph the function, and then you'll have an x min of 0, x max of 2 pi, y min of 1, and y max of 5. If you put all of that in, then this will be your screen on your graphing calculator, and the graph should match that.